Okay, in this lesson we're going to look at how to multiply radicals. Your essential question, what are 3 important things to remember when multiplying radicals? So the first thing here I want us to talk about is the product property of radicals. And it says that if we have the square root of a times b, we can separate it and put it as the square root of a times the square root of b. Most of the time what we're looking at is actually doing the reverse. It's saying that we can take 2 radicands, even if they're not like radicands, and we can put them all under the same radical sign. For example, let's look at it with some numbers. If we have the square root of 2 times the square root of 3, okay? This is just saying that we can put this all underneath the same radical sign, the square root of 2 times 3, which is simply the square root of 6. Okay, so that's already simplified. Okay, so let's look at some examples together. It says find the product in simplest form. Okay, now first I want you to notice neither one of these can be simplified. If we could simplify them first, it might make things a little bit easier. Otherwise, we're going to go ahead and put this together. 3 times 15 is 45. And so now let's break 45 down. 45 has the perfect square of 9 and 5. And so then this would be 3 the square root of 5. Okay, let's look at the next one. Okay, this one's a little bit different. I want you to notice because it has some coefficients. So the coefficients, I'm going to write this down. The coefficients multiply together and the radicals multiply together. Okay, so they have to be both be radicands, both be coefficients in order to put them together. So if we put this together, 7 times 3 is 21. Square root of 6 times the square root of 10 is the square root of 60. And now let's just check to see if 60 can break apart anymore. I believe that 60 can break down into 4 times 15. The square root of 4 is 2, so the 2 comes out. We multiply it with the 21 that's already there. And so that makes 42 the square root of 50. Okay, look at the next one. We've got the distributive property here. Remember, any radicals can be multiplied together. They don't have to be like radicals. So here we're going to distribute. 2 is not a radicand, so we're going to multiply it with a -3. So this is -6, the square root of 3. When I multiply here, radicand and radicand, coefficient and coefficient, so this is going to be -3, -3 times 1. The square root of 3 times the square root of 6 is the square root of 18. And now let's just make sure we can't simplify this anymore. Our first term looks pretty simplified. Oh, but I see here 18 has a perfect square of 9. So that's going to come out as a 3 and multiply with the 3 that's already out there. So -9, the square root of 2. They're not like terms. So we are done. Okay. Here's the next one. I'm going to put my numbers together. I'm going to put my variables together. 75 times 2 is 150. X times x cubed is x to the 4th times y. Okay, now let's look for some perfect squares here. Square root of 150, let's see, 50, I know 25 goes into that. I'm thinking about money. It would be 25 times 6. Got x to the 4th y. X to the 4th is a perfect square. The square root of 25 is 5. The 6 is solo with no pair. X to the fourth is a perfect square, which would be x squared, and then the y stays where it is. Okay, so there's several examples. I want you to now try the bottom two on your